One of the real strengths of Curry is its ability to combine functional data and image data to give clinically useful results. So let me give you an example here. We have a recording, a 64-channel recording from an electrocortical grid, and we have from the same person is MRI data and CT data. What we want to wind up with is a single display that has a subject segmented cortex, and on that cortex we want to place the electrodes, and we want to show the distribution and dipole source results for the spikes in the recording. So the first thing I've done when I've imported these two data files, I did it in such a way that they are co-registered using a volume-based procedure, and I want to verify that that was done correctly. So what I'm going to do is go to the CT data and adjust a threshold on it so that we're going to segment just the bony structures. And so when I do that, now we've got the bone segmented, and what I want to do is superimpose that on top of the MR results. So I'm going to export the data to image data 1, and now we see the bone structures in place on the MR data, and this is just showing that we have a very good co-registration between the two data sets. So now we can get rid of those. The next thing I want to do is create a boundary element method model from the MRI data. Is basically what I want to do is segment the cortex from the MR, and I want to segment the electrodes from the CT data, and then put the two data sets together. So first I'm going to create a BEM model, and I'm going to take one that's optimized for a grid, and this takes a few minutes or a few moments to complete. And now we've got the completed model. We've segmented the entire skin, we've segmented the cortex, and we've created a 3-compartment BEM model using the skin, the outer skull, and the inner skull. Now what I want to do is segment the electrodes, and that's a little bit tricky because you're trying to segment just the electrodes without any of the other structures that are in the CT file. So a way we can do that is kind of a neat little trick. We'll go to the outer skull compartment, and I'm going to import that to the CT data. So now you see we've got it here, and what I want to do is turn everything outside of that area into stop markers. Stop markers, it just means that those areas are not going to be included in segmentation. So now we can delete the boundary, and now we're only going to be considering what's in the gray areas. And by adjusting the threshold, you can see over here that at a certain threshold level we can get the electrodes without anything else, maybe a few other things, but it's clear enough to get the electrodes. Just to make it a little bit clearer, I'm going to go to segmentation and do dilated thresholding. And what this did was simply enlarge the area that had been segmented already. Just makes it a little bit easier to select the electrodes. Now I'll create a voxel mesh from that. And if we go into the localized part of the program, we can look at the 3D view results, and let's take a look at the right view. And I'm going to turn off the electrodes at this point, and so now we're looking at the results. What we have here is not a single 8x8 grid, which is what we have the data for. We also have additional grids and strips in here, and that makes this one just a little bit more difficult to do than you would normally encounter, but it's not too bad. So I'm just adjusting it where I can get easy access to all the electrodes. And I inadvertently added one, which I'll get rid of. So now it's just simply a matter of going through and clicking on the electrodes. And again, this is just the 8x8 grid, and you have to click on them in the same order that they appear in the functional data file. And that's why I'm clicking them in this particular order. There's a way to do this in an automated fashion, but doing it manually like this is a little more precise. Each time I'm clicking, you may notice that we're adding those positions to this list. You notice I'm not being overly obsessive about where I click, because we'll correct that right now. So if I go to the segmentation result and select project to nearby maxima, what that does, it centers the point within the mass that was segmented. So now we have the grid positions from 1 to 64. If we go back and look at the data, they were labeled from EEG1 to EEG64. The labels here do not necessarily have to agree, but if we want to make it a little easier just to keep track of, I'll relabel them. So first we'll make an 8x8 grid, and I'm just going to change the name to EEG01. Let's make it EEG1. And then when I click update, that changed all the labels so they agree with what we have in the functional data. So now I'm happy with that. I'm going to save those results, overwriting the file that I already have. And we'll just run through the import wizard real quick, see that they look correct here. And now when I look at the results, let's go to just the right view, and I'm going to take off the voxel mesh and the positions and look at just the electrodes. And we'll go ahead and look at the cortex. We're going to increase the transparency all the way. So now we have the grid on the cortex that we got from the MRI. I'm going to change the electrodes to be a color scale. Let's go to electrodes and change it to a color scale. And I'm going to reduce the size of them so we can see a little bit more easily. And now let's put up the functional data and the 3D view results at the same time. One of the things that happens when I do a recording, sometimes I get bleed through. This is something that does not occur if I'm not doing a recording, so I'll just sort of bear with this. Now let me change the cursor to a single one, and as we move the cursor through different points in the functional data, you can see the electrodes change color, and that's changing from negative, which is blue, to positive, which is red. And as we position this, we can get a good idea of where the activity is coming from during the spikes. To make it a little easier, I'll add the contour maps. I'm just going to reduce the line width a little bit. And if we go to the full view, I can get rid of some of that bleed through that you were seeing. Okay, so this gives the example for this one data point. Let's go back to this. And if we check another spike, we can see fairly similar looking results. And what I want to do now is add the dipole results on top of this. So we'll go back and select the head model that we just created, and I'll do just a simple fixed coherent result. And this takes just a couple of moments to compute. And so now we've got the dipole. I'm going to change the color just to make it a little bit easier to pick out. So make the dipole green here. And as we change the time point slightly, which I'll do with the keyboard, it's a little more precise, you can see the dipole change along with the electrode colors changing, showing the voltages, as well as the maps changing. So this is from one spike, and let's say we like that, and I want to save it. All I have to do is right click and have several options. I'm going to add it to the report, and I'll show you that momentarily. Now let's take a look at another spike. And again, I'll step through, and this looks pretty good. Let's say also that we want to define certain other areas. So let's go in and let's say that we've determined that these areas are speech. Yes, I know this is the right hemisphere, but just for demonstration's sake, let's say these are speech areas, 19, 20, 27, and 28. So what I can do is go back into the import wizard and relabel these so that 19 will be speech, 20 is speech, 27, 28, and now when we look at the map, you can see that it's labeled them speech 1, 2, 3. So these are areas that the surgeon would most likely want to try and avoid, and that's the purpose of relabeling. And if we wanted to save this, again, we'll just add this to the report. And maybe we want to look at one more spike. And maybe we'll take this one, do a nicer view of it, and we'll save that to the report. Now what the report is, down here at the bottom, I'll select it, and at the top of it is a heading which you can set up to be any way that you would want it to be. And then here are the pictures, and we can always add in text any place we like. So if there's some kind of text we wanted to add, we could simply do that. And if there were some results that we wanted to take that were meaningful, let's just say for some reason we liked these results, we can just highlight it and copy to the report, and now those results appear as well. And then this is something you can save and open up in just about any Windows application. So this gives you an idea. Let me just get rid of these results. I want to show you one more thing. Let's take a look at image data 1. And so when you look at the MRI data, you can see the dipole in relation to on the grid. All right, so this gives you an idea of how Curie can be used in more of a clinical setting, and also illustrates some of the major functionality and some of the unique functionality that's in Curie 7 that allows you to combine these different types of data sets and to give a clinically useful result.